Hello, this is question 8 on your OCR MEI from June 2022 paper 1. So you have a particle moves in the xy plane, so the position at time t seconds is given by these parametric equations, yeah? And t is between minus 3.5 and 3.5. The units of distance are meters, and the graph shows the path of the particle and the direction of travel at p, which is 8,4. Find dy by dx in terms of t. So remember to derivate parametric equations. Dy by dx is going to be equal to dy with respect to the parameter, dx with respect to the parameter. So it's quite simple. Dy, y is this one, so dy by dt is 2t divided by derivative of x. So it's going to be 3t squared minus 8. 3t squared minus 8. And that's the expression. We cannot do much more with this one. B, hence, so using this information, show that the value of dy by dx at p is minus 1. So we have to substitute in this expression the point. For the point, we know the coordinates, we don't know the parameter, and we need the parameter to find dy by dx. So what we are going to do is to find the parameter at point 8, p. For that, so p is 0.84, and we know that x is t cubed minus 8t, and y is t squared, just t squared, t squared. So we are going to substitute a there. I think this one is easier, so I'm going to substitute the y by 4, find t, and see if it satisfies. So this is 4 is going to be t squared, which means t is plus or minus 2. To decide, we are going to check which one of these two values satisfies this other equation. So when t is 2, we have 2 cubed. So if I go back to this one, when t is 2, I have that x is 2 cubed minus 8 times 2, which is 8 minus 16 is minus 8. So this one is not, because we need that x is 8, and we are going to check with the other just in case. So x is going to be minus 2 cubed minus 8 times minus 2, and this is minus 8 plus 16, which is 8. So this one is the right one, yeah? The parameter is t minus 2. When the parameter is t minus 2, the derivative is going to be derivative when t is minus 2, dy by dx is going to be equal to 2 times t, so 2 times t divided by, I'm just using the expression that we found, 3t squared minus 8, 3t squared minus 8. This is minus 4 divided by 12 minus 8, 4. So this is minus 1. Yeah, and that's where we have to find. That's what it says here. So that is minus 1. Find the time at which the particle is traveling in direction opposite to that at p. So we have the direction at p. And I know it looks like if the gradient is minus 1, the opposite direction would be 1, but that would be perpendicular direction. It wouldn't be the opposite direction. So if this is the direction, so if we have this line, yeah, it's not going. So if you have this direction, opposite direction would just mean that way, yeah? But the same gradient, and dy by dx is giving us the gradient. So what we are going to find is another point somewhere, probably here, where the particle has the same gradient, yeah? Because the gradient is the same, it's just this line. And then we are going to see that is going the other direction. So we are going to make the derivative equal to minus 1 again. We are going to see that that happens when t is minus 2 and when t is something else. That something else is the time that we are looking for, yeah? So 2t, 3t cubed. So for c, we are going to make the derivative equal to minus 1 again. So 2t divided by 3t squared minus 8 equal to minus 1, which means 2t is going to be 8 minus 3t squared. If I reorganize, I have 3t squared plus 2t minus 8 equals 0. And when we factorize this expression, we have 3t minus 4 and t plus 2. As we say, one is the parameter that we knew, the t equal minus 2, and the other one is t equals 4 third. And this is the other time where the particle has the same gradient, but then is going in the other direction, yeah? So this is the time. We know it's in the other direction because we only have two values. If we had more, we should check if it's going in the other direction. But if I have only two values, and I know this is in one direction, the other must be in the other direction, yeah? So that's the time. And it's in seconds, yeah? Because they tell us the time is in seconds. Then find the Cartesian equation of the path given x squared as a function of y. So what we are going to do is eliminate the parameter between the two equations that I have. So I'm going to copy them again here. So for t, I have that x is t cubed minus 8t, and y is t squared. You know that these questions, you can do them in a few ways. I'm going to make t the subject here and substitute in the other. So I'm going to do the square root, and then I'm going to go to the other equation and substitute the t. So x is going to be t cubed, so this cubed, minus 8 times t, which is y 1/2. This is y to the power of 3/2 minus 8y 1/2. They say, given x squared as a function of y. So what we are going to do is square this expression. So I'm going to square the left-hand side, and I'm going to square the right-hand side. So I have x squared, and then I have a binomial squared. So it's going to be this one squared. This one squared is y to the power of 3. Minus, because I have a minus, 2 times this one times this one. So 2 times 8 is 16. And then I'm doing y to the power of 3/2 times y to the power of 1/2. Remember, when I multiply powers, I add the exponents. So I have 3/2 plus 1/2 is 4/2, which is 2. So this one is y squared. And then I'm doing this one squared. So it's 64. And y to the power of 1/2 squared is y. Yeah, and this is the expression that we are looking for, x squared in terms of y. Yeah, and that's all with this question.